Alright, welcome to my project for CSCI 549. This is going to be a presentation on parsing, taking a context-free grammar in Chomsky normal form and applying that to this parsing algorithm. I believe it's the CYK algorithm, which is a bottom-up parser. So they basically what it looks for the different derivations of substrings, starting from one letter to two-letter combinations, three-letter combinations, four-letter, all the way on up to the length of your string. So each row is going to be the length of the substring, and each column here is the substring starting with character here at the bottom. So table, in this case I call it T, table 1, 1 is going to be the different substrings that forms just the letter A. And in this case, that's going to be the product rule starting with A, produces A, and X produces A. So we go ahead and fill that into the box here. That's easily done for the first row here, because we're just looking at substrings of length 1. So substring A, substring A, substring A, substring C, and substring D. And then so this is the work that the actual algorithm does. We can see here, this starts with row 2, just because row 1 is just simply looking at the context-free grammar and plugging in what rules produce these. That's just the substrings of length 1. So starting with the second row here, we're looking at substrings of length 2. So starting from the left-hand side, this box right here would represent substring A and A. So basically length 2. And then the way do we figure out what production rules produce the substring AA? We basically take the Cartesian product of their two substrings, so of substring A and substring A. We take the Cartesian product of those two, the derivations of those, which are A and X. So this is what produces right here, Cartesian product of table box 1, 1 and table box 2, 1, which is 1, 1 and 2, 1. So that produces AA, AX, XA, and XX, which is down here, AA, AX, XA, and XX. So we take these combinations, these are all the combinations that produce substring AA, and we go over here and look for them in our table, our production rules, the grammar. So we can see that AA is produced by S, and AX is produced by X. We cannot produce XA or XX, so we cross those out. These are the only two rules that can produce substring AA. So we enter that into the box here. The same thing is done across the columns here. So this column here, table 2, 2, box 2, 2, is also for the substring this AA right here, which is the same one as the one we just did. So that would be SX. Table, this would be 3, 2, looks at the substring AC, two-letter substring, and we take the Cartesian product of that, which would be AC and XC. That's going to be right here, table box 3, 2. That's the Cartesian product of box 3, 1 and box 4, 1, 3, 1 and 4, 1. So AC and XC. The only way we could produce AC would be over here, production rule Z. So we fill that into the box. So the last substring of length 2 would be these last two, CD. And that is the Cartesian product of box 4, 1 and box 5, 1. That's done right here, which is CD and CZ. And now we look, the only product that produces CZ is production rule Z. NS, sorry, ZNS. So that we enter those two right there. Those are the two production rules that can produce the substring CD. So moving on to row 3, it gets a little different because we are looking at substring 3 of length 3. And the way we can produce, there's two different ways we can produce substring of length 3 AAA. It would be to break it up into A and AA, or the AA and then A. So we have to look at all these two different combinations to fill in box 1, 3. So we take, to break it up, we take this box here, 1, 1, which would account for this A of the substring AAA, and then we take this box right here, 2, 2, which accounts for this substring of AA. And we apply the same method, the Cartesian product. So we take AS, AX, XS, and XX. And that's down here. This is this first basically union or Cartesian product. The next one would be to do the second combination of substring AAA, which would be AA and A. So substring AA is taking care of this box right here. And then the single substring of A was taking care of this box right here. So if we take the Cartesian product of that, it would be SA, SX, XA, XX. And all those combinations are written down here. The only production rule that can produce, whether it be 1 and then 2 or 2 and then 1, would be AX. And that's going to be rule X right here. So going on to, so basically it's just the same across the row this way. So box 2, 3 is the same one. This is the one we're working on right here. This is going to be the substring AAC. And again, that can be broken down into two combinations of substrings of A and then AC, or AA and C. So we again, down here, we take that, the Cartesian product of both combinations. So one of them is going to be AZ, XZ. That's for the first substring A and then substring AC. And then we do the same thing for the second combination of AA and C. So that's going to be SC, XC. And then I'll take care of this box right here. That's box 2, 3. All the different combinations here. The only one that comes up with that combination is going to be XZ, and that is by production rule A right here. So we put an A in that box. And then for this one right here, it's going to be substring 3, length 3 ACD. And again, we apply the same general principle. That could be broken down into two substrings of length 1 and 2, and then 2 and 1. So the first one we're going to be taking care of substring ACD is going to be length 1, which is A, this box here, and then length 2, which is CD. That's going to be this box here. We take the Cartesian product again of these two boxes. That'll give the different combinations of non-terminals that will produce the substring ACD. And then again, we do it again for the second combination of AC, substring length 2, and then D. And that will be box here, Z, which is AC. That's the only production rule that produces, non-terminal production rule that produces AC. And then D, which is going to be this one right here. So we take ZD and ZZ. That's this line down here. And we can see that, again, the only production rule that can produce the substring ACD is going to be A. So with row 4, this is going to be substring length 4. It gets a little different now. We're going to have 3 combinations. So this is going to be substring AAAC. This can be broken down into 3 different combinations. We can go substring length 1, or length 1, which is A, and then length 3, which is AAC. That'll be one combination. We'll do A, AAC. Second combination would be 2 substrings of length 2. So we'll go AA, AC, and then last combination would be substring length 3, AAA, and substring length 1, C. So again, we look at the different boxes here of the derivations that produce these substrings, or in this case, the bottom one would be produces terminal values. And this is going to be box 1,4. So the first combination would be to take this first string A, or non-terminal A, and combine that with the length 3 string here, which is this box here, and then this box here for the substring length 3. So in this case, it's AA and XA. And we want to make sure we keep these in the correct order. We never want to multiply this way, because this will produce incorrect non-terminal values. We always want to keep it going left to right. So this one will produce AA and XA. A combination of string length 2 and string length 2 is going to be these 2 boxes here. So we have SZ and XZ. And then finally, substring length 3, which is AAA, combined with this last one of length 1, which is C. That'll be this box here, and this box here, which is just XC. And those are all produced right here: AA, XA, SZ, and XZ, and XC. The only production rules that produce those in that order is S and A. So we enter that in this box here. We do that for the same one here. This is going to be this substring of length 4, AACD. Again, 3 combination breakdown. We're going to go length 1 with length 3 substring, length 2 and length 2, and then length 3 and length 1. So again, we do that by producing the Cartesian product of each box. So this is going to be substring of A and ACD, which is this one right here. This means that this production rule can combine, you can combine other production rule with this rule to produce the same substring ACD. So we take the Cartesian product of that, which is going to be AA and XA. Second one would be break down into 2 lengths, 2 substrings, which is these 2 right here, SS, SZ, XS, and XZ. And lastly would be length 3, which would be this box here, and length 1, which is AD, AZ. And that'll go in this box right here, 2, 4, which is this line right here. AA, XA, SS, SZ, XZ, XS, XZ, AD, AZ. And then the only ones that can produce that substring of length 4 for the different combinations are S, A, and then A again. We don't write the second A, the duplicate, because it's already taken care of with this one. So this is just SA. And lastly, the way we break this one up is going to be, we basically break it up in the different combinations. For the substring length 5, it's going to be 1 and 4. It's going to be 2 and 3. It's going to be 3 and 2. And then it's going to be 4 and 1. So there's 4 different combinations we can use to break this string into substrings to make it a little bit easier for us. So the first one is going to be substring of length 1, which is this A, combined with the substring of length 4, which is AACD. We again take the Cartesian product, which is AS, AA, XS, and XA. We do that again for the second combination, AA, combination of substrings, so AA and then ACD, which is SA and then XA. Again for substring of length 3, which is AAA, and substring of 2, which is CD. That'll be taking care of this box X, S, and XZ. This box right here gives us the production rules that can combine to make the subscreen CD. So that's how we produce that. And then lastly, we want to go substring length 4, which is AAAC, and then combine that with the last letter D, which will be SD, SZ, AD, and AZ. So those different 4 combinations are written down here by box number. And then so that produces all these rules right here. The 3 that we can find in our grammar here would be AA, XZ, AD, and those are produced by rules starting with the non-terminals S, A, and A. So we write S and A here. To know that this grammar is accepted, we need to make sure we have the starting production rule, which is S. In this case, this is going to be our start. This needs to be in this box right here for this grammar to be accepted. We can see these other tables that I've done. All the boxes here have S, and we can see in some of these are all accepted. We can see in some of the ones that are not accepted that there is no way to make this substring of length 5. We can also see that there is some ways to make a substring of length 5 here, but it does not begin at production rule start, which is S. We can make these strings starting at A or X, but not at our start rule, S. So this is, even though we have here, this is still not accepted. We can see that every table, though, every string that is accepted will have a derivation tree with that here. And we can also see that even though that there is sometimes no combination of non-terminals that can make certain substrings, we are still able to accept that string through other combinations of substrings. So I hope you enjoy watching this. I had a blast putting this together for you, and I wish I could have coded it into a program, but I hope that you can see that I do understand the concept of context-free grammar. Thank you for watching.